Hey brilliant minds, let's turn these function questions into easy marks. Functions are an important part of paper 1 in grade 11 mathematics. They carry a significant number of marks in both the June exams and the final examinations. If you can master functions, you're already setting yourself up for success. In today's lessons, we will work through a past paper question focused on a specific type of function, the hyperbola. We will break down the question step by step so that you can understand the concepts and approach similar questions with confidence. If the full solution ends up being too long for one video, we'll split it into parts to make sure we cover everything thoroughly. Let's get started. Right. So, this is a past paper question as mentioned, and we're given g of x, which is a hyperbola. It's a hyperbola function. All right. We know that it's a hyperbola function because the general formula for hyperbola is y is equals to a over x minus p plus q, where now your p is your vertical asymptote and then your q is your horizontal asymptote. Right. Now, this formula given, it is in that form, where this is our P and this is our Q, and 1 as our A. We know that it is important to understand the sign of A so that we know which two quadrants will our function be drawn at. We know that if A is greater than 0, which means A is positive, we expect our graph to be on the first and the third quadrant, right? And we know that the hyperbola is made up of two arms. If your A is then a negative, we expect our graph to be on the second and fourth quadrant. So this will be our two arms. Okay. Right. Question 4.1. Write down the equation of the asymptotes of G. We are looking for the asymptotes, so that's a plural, meaning that we have two asymptotes for the hyperbola. Right, so let me just make a young space here where we'll fill in our solution. For 4.1, the vertical asymptote will be associated with x, right? So our first asymptote is x minus 1 is equals to 0, which means x is equals to 0. This is the equation of our first asymptote, the vertical one. The second asymptote, which is the horizontal one, is associated with y, right? That will be y is equals to 2. So it's similar to saying y is equals to q. And why do I emphasize vertical and horizontal asymptote? So that it is easier for you when you draw your function to correctly draw the asymptote. So for example, what do I mean by vertical and horizontal? What is the line y is equals to 2? So if we have 2 here, so this will be 1, this will be 3, and other values. 0, minus 1, minus 2, minus 3. So if you look here, when you draw a dotted line at 2 there, and maybe let's write coordinates for x as well. This is 1, this is 2, this is 3, minus 1, minus 2. That should be enough. So let's say we have a point there, we have a point there, we have a point there, and maybe we have a point here as well. Now, if you look at the coordinates, let's call this point A. The coordinates of A is 1 and 2. The coordinates of B is 2 and 1. Sorry, 2 and 2 there. The coordinates of C, which is just this point there, would be 3 and 2. Now, if you look here, there is something that is common between the coordinates, and that is y. All the y values there are just 2. Hence, a horizontal line will be y is equals to. Because remember, when we're looking for the function of a line, we're looking for something that stays constant, that is unchanging within that line, or a rule with regards to that line. And in this case, it is y is equals to 2. Hence, a horizontal asymptote will be known as y is equal to a value. Okay, now for a vertical asymptote, let me use a different color. And let's say we have a vertical line at 1 there. So we apply the similar technique. If we have a point here, let's call that point D. D will be 1 and minus 2. If we have a point here, let's call it E. E will be 1 and minus 3, right? So even with these two coordinates, something is constant. And what is constant there is your x coordinates being just 1. So a vertical line will always be defined by x is equals to a specific value because that value is unchanging in that line. So for instance, this is x is equals to 1. So this is me just clarifying why we speak of vertical and horizontal asymptote. Okay, right. Those are our two answers for 4.1. X is equals to 1 and y is equals to 2. Now moving to 4.2. Calculate the intercept with the axis of G. So the word intercept meaning we're looking for both x and y intercept. Intercepts here. Okay. So we know when we calculate the y-intercept, the rule says we must make x is equals to 0, right? The formula is given by g of x. G of x is the same as y, is equals to 1 over x minus 1 plus a 2. Just make sure correct. Now for the y-intercept, we make x is equals to 0. So you'll have y is equals to 1 over 0 minus 1 plus 2. This means we have 1 over a negative 1 plus 2. A positive divided by a negative is just negative. So you'll have negative 1 plus 2, which is then 1. Meaning we have the coordinates 0 and 1 because we made x 0. Okay. Now moving on to your x-intercept. So for our x-intercept, we make y equals to 0. The formula of the graph is given by 1, right? It is 1, okay? 1 over x minus 1 plus 2. So here we make y 0. This will be 0 is equals to 1 over x minus 1 plus 2. Taking 2 to the other side, we then have minus 2, 1 over x minus 1. Multiply both sides by x minus 1. What you do on the left, you must do on the right. Multiply by x minus 1. This cancels that. Then we'll have here minus 2 into x minus 1 is equals to 1. The minus 2 multiplies the x and the negative 1. Then you have minus 2x plus 2, because negative and negative multiplied is a positive, is equals to 1. Minus 2x is equals to 1 minus 2. Okay, that will then be negative 2x is equals to minus 1. Divide by minus 2, divide by minus 2. X will then be equals to a positive half. We then have the coordinates half and a 0. Okay, let's just go on to the second video where we then look at the rest of the question 4.3 up to 4.6. Catch you on the next one.